Good morning to all. Today I shall be discussing on short question part 2. In continuation to our part 1 on the short question and answers, today I shall discuss some more questions which may be useful for deserving young engineers and my beloved friends. First of all, I am very sorry to say here there are innumerable typing mistake or printing mistakes which I cannot correct due to corona pandemic. So I shall be happy if you kindly bear with me. Yesterday we have discussed about 17 questions. Today I shall be discussing some questions, short questions. And first of all, the question is a deep foundation having a width of B and depth of df. And what shall be the ratio to determine deep foundation? Given answer is d by b less than 1, d by b equal to or greater than 2, d by b greater than 2, d by b, d means df by b greater than 5, none of this. Actually, shallow foundation is when d by b less than 1 or equal to 1. So this is the criteria of shallow foundation. So it implies that there are two types of foundation. One is shallow foundation, another is deep foundation. When df by b greater than 1 is deep foundation. Nowadays, irrespective of width, depth of foundation may be provided at any depth. For 2 meter width of foundation, depth of 5, maybe 3 meter or 3.5 meter, even up to 4-5 meter. But these we are called shallow foundation. Although it was defined d by ratio, if it is greater than 1, then it is deep foundation. But we are not saying that deep foundation. Deep foundation we are saying normally. We are normally saying deep foundation means well foundation or pile foundation, etc. only. Now next question. What is the difference between shallow foundation, the shallow foundation, and deep foundation? The difference between the shallow foundation and deep foundation. Given answer is df by b ratio. The foundation at a very shallow depth, open cut excavation, foundation works is open to all, none of this. You see, technically df by b ratio is the deciding factor. This is the df by b ratio. Whether we are commonly saying it is shape foundation, it is some deep foundation, shallow foundation, this is not the criteria. Criteria is df by b as explained in all codes. If df by b is criteria for difference between deep foundation and shallow foundation, then a foundation of 1.5 meter is provided at a depth of 2.5 meter, then what shall be foundation type? Given answer is shallow foundation, or it is footing foundation, or it is deep foundation, or it is isolated foundation, and none of this. It is termed as isolated foundation. Neither it is shallow foundation nor deep foundation, it is isolated foundation. For next question, raft is generally termed as shallow foundation, although the foundation is provided at a depth 3 to 6 meter below ground level. A raft size 15 meter wide and 32 meter length. The size is given here 15 meter and 32 meter at a depth of 5.8 meter below ground level. Shall it be called shallow foundation? Given answer is shallow foundation, floating foundation, deep foundation, raft foundation, none of this. This shall be termed as raft foundation only. As stated D in the above question, weight of excavated soil equal to all loads on raft, including the self weight of the foundation system, termed as raft foundation or floating foundation or buried foundation or deep foundation, and none of this. When excavated soil is equal to all superimposed load, including the self weight of the load, then it shall be termed as floating foundation. Weight minus soil weight equal to 0. Applied load minus soil weight equal to 0, that is floating. There shall be no applied force at the base, because it is interior load is already there as such, so it is floating foundation. Next question, as stated in D earlier question, foundation dimension appear to be L by B greater than 2, preferably rectangular in size. Then why not this term rectangular foundation? Given answer, all load bearing columns are resting on single base. Since the base behave like rigid foundation, shape and size are required for SBC analysis only. Monolithic foundation, none of this. It is not rectangular foundation, it is monolithic foundation, so it is called raft foundation. It is called raft foundation. It is not rectangular foundation. If there are lot of different sizes of individual rectangular foundation. In such cases, it shall be rectangular foundation. Here it shall be wrapped foundation, since all loads are applied in the same foundation. A foundation having B equal to 1 meter, L equal to 30 meter. What is the foundation system? Strip, continuous strip, rectangular, none of this. The answer is continuous. This is the answer, continuous. It is continuous. It is not continuous rectangular or nor continuous strip. It is continuous foundation. In most of circular structure, a circular strip is provided. What shall be this foundation system? Ring. Given answer is ring foundation, rafter raft. Some says it is ripter raft, circular strip. There are two circular strip. It is because of printing mistake. None of this. It is ring foundation. When circular ring is provided below foundation, then it is called ring foundation. In a plastic clay soil having shrinkage and swelling potentiality, generally what type of prevention is taken? Given answer, foundation sufficiently below stable water level, or chemical treatment, or pile foundation, or ground improvement. If the clay is having shrinkage and swelling potentialities, then the best option is foundation to be provided sufficiently below the stable water level. Or in case of hilly streets, then we cannot, if it is water table is sufficiently below, say about 50 meters below water level, in such cases we cannot go up to that extent, but we must consider one thing, that due to evaporation or due to absorption of heat from sunlight or whatever other reason, the soil moisture produce variation up to a maximum of 1.5 meter. In such cases, if it is sufficiently water level is sufficiently below, in such cases it should be provided sufficiently below, say about more than 1.5 meter to any depth. In a soft compressible soil having very low shearing resistance, where construction is too costly, will the shearing strength can be increased by improving the ground improvement technique, and what shall be the best suited method? Soil nailing, and given answer is soil nailing, chemical treatment, chemical soil stabilization as per soil condition, jet grouting, or none of these. Best solution is soil nailing is suitable for some type of soil, or soil chemical soil stabilization is suitable for some type of soil. Cement grouting or jet grouting is also suitable for some type of soil, but these are not working all type of soils. There are some different soil require different treatment. So the correct answer is as per soil condition. This is the correct answer, as per soil condition. If it is soil is say about jointed or fractured rock, then that no, it is compressible soil. So in we have to, if it is moisture is heavy, highly oversaturated, then chemical soil stabilization is suitable, or jet grouting in some soil is loose and jet grouting is suitable. So as per soil condition, the correct answer is as per soil condition. In situ soil moisture is 23% and OMC of soil is 19%. This is in situ soil moisture and this is the OMC is 19%. The thickness of this stratum is 1.5 meter only, very nominal thickness, and followed by very dense, well-graded coast-grained sand. The foundation depth cannot be seen since it was designed for gravity flow of water. Is there any possibility of reduction of soil moisture content by 3%? 3%, because we require it is say it is 19. If we can reduce it is up to this 23. In situ soil moisture is 23. If we can reduce 3%, then it will be very close to OMC. So moisture content by 3%, enabling to mechanical compaction. If yes, putting a layer of crusher dust, spreading over a layer of lime powder, putting some amount of calcium carbon, probing some heating elements. It is not probing, providing some heating element, none of this. Now, if yes, our best answer, correct answer is putting a layer of stone crusher dust, because water absorption is crusher dust varies from 9% to 11%. So if that crusher dust is sprayed over, a layer sprayed over, this 23 shall be decreasing to 11%, 9 to 11%. So that much of water can absorb. So this layer is putting a layer of crusher dust. Now, if no, what shall be best alternative? In a same question, the same condition, there are two options is given. If yes, then one answer. If no, what shall be the alternative? Given answer is replacement of bad materials with some good material, soil stabilization, providing some granular aggregates. It is probing. It is not probing. It is providing. Earlier I said there are a lot of typing mistakes. providing short column foundations, none of this. These are given answer. The replacement of bad material with some good material shall be the best option in this case, because 1.5 meter can easily be excavated and removed, then that will be less cost. Cost shall be very less, going instead of all this costly proposition. Soil stabilization will be costly proposition, provision of some granular aggregates, that will be costly proposition, providing short column foundation, that also be costly proposition. So it shall be the best answer. Next question. A few samples of sand quarry were tested laboratory, and fineness modulus FM, which is required for mixed design and for concrete RCC works, was found to be 2.2, which is not suitable for M25 grade of concrete. Question is there any possibilities of raising fineness modulus from 2.2 to 2.6? If yes, answer is giving adding some amount of crusher dust, adding small size crusher aggregates, changing aggregates gradation, adding more cement, none of this. Here, if we add 30% of crusher dust, then 2.2 shall be going to 2.6. Normally, where class 3 sands are not available, like in our Assam, in our northeast, in some places are there, normally Barak Valley, in Mizoram, in Nagaland, in those places sand are, even they will be not, these are the class 4 sand, where fineness modulus is less than 2. In such cases, we are adding 30% crusher dust, and we are getting 2.6 and little above. So adding crusher dust is the correct answer. Same question, if no, what shall be the best alternative? Given answer is remix design, provide larger dimension of concrete member, adding additional and extra cement, adding extra small size aggregates, none of this. Here, if it is not possible to go to attain 2.6, in such cases we should go for revised mixed design. We should go for revised mixed design to get M25 grade of concrete. Now next question, a foundation is designed in fine grain SP soil, adapting depth of foundation as 3 meter below ground level. During excavation, the water level was encountered at 1 meter below ground level. You see, our foundation is provided as 3 meter, and we are getting the subsoil water level during excavation, during execution, we are getting at 1 meter below ground level. But as per design, the excavation required to be done up to 3 meter. It is a fact that excavated below 1 meter, sand boiling and sand blowing shall occur. What measures be taken to avoid the loosening state? When we shall excavate below water table in this type of soil, fine grain SP soil, these are very small particles. In case of cobbles and boulders excavation, in case of excavation below water table, there shall not be any problem. But here 2 meter, we are getting water table at 1 meter and we have to excavate up to 3 meter. So 2 meter excavation in water, underwater, it is not possible. There shall be sand boiling and sand blowing. So the best precautionary measures is well point pumping to lower the water table. Normal pumping will not give any benefit, so there shall be well point pumping to lower the water table. Or others, if you go for cement grouting, prevent water, providing steel shuttering, sheet piling, none of this. Actually, this will be the best option is well point pumping to lower the water level. As stated in this question, if the foundation is at all provided at 1 meter instead of 3 meter, what type of remedial measures shall be suitable without changing the foundation design? Given answer is backfilling shall be made for 2 meter for equal surcharge benefit. Foundation may be anchored with underrim pile foundation. Peripheral cement grouting to increase the weight of soil, providing a thick PCC at ground level. None of this. The backfilling shall be made about 2 meter above the foundation, which shall give same surcharge load as we need for 3 meters. So this shall be the simple backfilling shall be made for 2 meter extra. As stated in C, excavation is made at up to 3 meter without taking precaution. What shall be result? Soil liquefaction, sand boiling, sand blowing, wall collapse, none of these. Normally what happens without taking necessary precautionary measures, if we excavate in underwater, say about 2 meter, then soil boiling shall start it. It shall be resultant shall be sand boiling. As stated in C, if excavation is made up to 3 meter without necessary precaution, what shall be the shear strength of soil at 0? The shear strength of soil That means at what type of shear strength there will be soil. Without taking, if we anyhow excavated up to 3 meter below ground level, that means 2 meter in underwater, then what shall be the shear strength? 0 equal to pore water pressure equal to overburden pressure partially lower than earlier shear strength. Now none of this. Here equal to pore water pressure. Shear strength shall be equal to pore water pressure, because the whole soil has started boiling, so soil has no resistance, only the pore water pressure shall produce some amount of resistance. As stated in C, the foundation is provided at 3 meter after making excavation without taking adequate precaution, and may subsequent expected problem of the foundation. What may be subsequent expected problems? If we construct the works, we complete the works without taking any resource of anything, what will be the future problems we can expect? Given answer is total failure, tilting of foundation, settlement may exceed the permissible limit, or no problems, none of this. In such cases, the foundation shall be tilted. There may not be a total failure, but foundation shall be tilted. So answer is tilting of foundation. As stated in C above, if the foundation base is enlarged after making excavation up to 3 meter, without making proper precaution, what shall be the effect to the foundation? Given result is high cost, total failure, perfectly safe, excessive settlement, none of this. First result is high cost, because making a large base in case of sandy deposit in underwater condition of 2 meter is highly costly. Next only that other factor will be coming. Number 1, high cost. A foundation was designed with a gross SBC of 2 MPa at a depth of 2 meter ground level, and during construction a very hard pre-consolidated stratum was encountered at 1.5 meter below ground level, having a gross SBC of 2 MPa. Whether the foundation shall be at 2 meter below, given 2 meter below ground level. You see, the question is at 2 meter below ground level, SBC, gross SBC was 2 MPa, and here when we encountered this very pre-consolidated stratum as 1.5 meter below ground level and having a gross SBC of 2 meter, whether we shall provide the foundation of 2 meter below ground level, not given answer is not necessary. At 2 meter only, at 1.5 meter after checking the design, none of this. Because you see, we are concerning about the SBC, gross SBC only, since it is getting at 1.5 meter, answer is 1.5 meter only. A hard soil stratum was encountered at a moderate slope of 1:1. Whether the foundation can be provided at a slope of 1:1. Given answers are 1:1. Question answer 1, no, does not permit IS code. Can be provided as per slope geometry at same elevation at 1:1.5 slope, none of this. Out of this answer, you see, the 1:1 is a 45 degree. It is a very steep slope. Very steep slope. There are a lot of complications if we go for the lower level also. In such cases, excavation at upper level will be too high, where earth pressure will be too. Another structure, retaining wall will be required to be provided there. So the correct answer is no, does not permit IS code. Does not permit IS code. Code number IS 1904. Next is, during construction of a retaining wall, slope soil started sliding, having lot of damages of nearby area. An inquiry was conducted by few experts and commented followings of this, which may be out of this, which may be improper design. Given answer is 1, improper design, no construction modalities, excessive vertical excavation, not constructed phase manner, none of this. Answer is excessive vertical excavation. When we excavated for trenches for foundation soil, if it is little higher, say if up to 1 meter or 2 meter, it is does not a problem. But for higher thickness, higher depth, say about 6 meter, then we have to go for slope excavation or benching excavation. So the landslide was happened only because of excessive vertical excavation. A few years back, a multi-story building was constructed at China and handed over the owner. During construction of an adjacent building, the excavated material was dumped near the old building. A few days later, the old building was collapsed. What may be the probable reason behind the collapse of the building? The question answer is improper design, soft story, no shear bracing, additional load due to dumping of excavated materials. I say, if it was improper design or there are some soft story, if there is some earthquake was there. In case of some earthquakes, these are improper design, soft story, no shear bracing, these are applied. But here it is few years back, say 10-15 years already passed without any single line crack as in the question. So reason is additional loads due to dumping of excavated materials, because that portion is heavily loaded. So the applied load will be increased. One side increase the applied load, so building has collapsed. Do not forget that for a multi-story building, if one column is collapsed, then whole structure shall collapse. That should be, please keep in mind. For especially multi-story building, say more than 4, 5, 6 story, say if it is a 10 story, 15 story, if one foundation, one column is failed, the entire building shall collapse. During last Manipur earthquake, some buildings of Ma Market complex were collapsed. Almost all the buildings are Xerox type structure having same dimension and a foundation of the superstructure. What may be the actual reason of collapse? Given results is poor workmanship, heavy concentrated load due to earthquake, poor soil condition at collapse portion, presence of humus material below collapse foundation, none of this. See, that is a big market. It is a very big market. It is the biggest market. There are a lot of buildings. All the buildings were constructed by National Building Corporation, Construction Corporation and BCC. So, few buildings, out of these few buildings were collapsed. If it is heavy concentrated load due to earthquake, then other columns, other buildings also. These are collapsed mainly because of poor workmanship at that portion. Poor workmanship. Maybe there are a lot of workmanship criteria is there. Curing and time allowed for construction is not easy paper make work. There shall be some time required for setting, removal of shutterings. Lot of other chapters are there. So there may be some other reason for this. There are some poor workmanship. Some buildings were collapsed. In this Xerox structures, all the buildings have same design, one design throughout the market. One build design, so same dimensions. So there is no question of anything. A factory building was constructed in 1988 and suddenly during 2016 fire broke out, which was lasted for several hours. After control of the fire, no one can go near to the building. After about a month, concrete members, column, beams, slabs were thoroughly inspected and with some sophisticated tests were conducted. It was revealed that the concrete members behaving like friable material and visible cracks were developed. Why these cracks had developed? Given answer is because I was specifically associated with this project. I was personally associated with this project with expert committee. So our question answer is number 1, thermal expansion of reinforcement. Number 2, cement of concrete damaged by heat. Instant cooling of highly heated concrete, high concentration of carbon dioxide. Out of this, what is the reason? Because for friable nature, outer surface can be damaged for other region, but since there is some cracks inside, cracks are there. It is mainly because of thermal expansion of reinforcement. So under tremendous pressure, say about 300 degree or 400 degree, whatever it may be, a biscuit factory was burning. No, there are some oils are there. There are some other materials are there which are heavily explosive. So for this reason, thermal expansion was due to high temperature. So all cracks have been developed. Answer is 1, thermal expansion of reinforcement. Next question. A bridge under construction and 3 prestige girder was constructed completely. All of a sudden, all 3 girders fall down one after another in fair weather condition. What may be reason of falling down of the girder? Bearing failure, guardrail failure, both 1 and 2, bearing and guardrail failure, storm, none of this. Answer is bearing and guardrail failure. First fail the bearing, then it affects guardrail fail. So 3 girder falling down. During 1950 Assam earthquake, damages of building were reported very less, although the magnitude was quite very high. What was the reason? Given answer, high-rise buildings were very limited. All high-rise structures are pyramid-type structure. Good quality materials, good workmanship, none of this. Out of this, all high-rise structures are pyramid-type structures. There are few tall structures are there, say about 30 meter tall some are 20 meter tall. There are these type of high stacks are there, but all these are pyramid type stacks. So it has no damage. During excavation of foundation trenches, generally excavated materials were taken out from the excavated area in spite of carrying cost. So, in spite of carrying cost, that means why the extra cost is necessary. The carrying cost, why we are paying the extra cost? Ensure is giving to avoid wall failure. These materials may fall down in the excavated pit to avoid soil depression under load of excavated material, to prevent heap of base material. None of this. Correct answer is to avoid the wall failure. If we dump near the side of the near the excavated trench, this due to load, cut sharp wall shall be failed. There are different type of excavation methodology. One, mechanical excavation, manual excavation, open cut excavation, undercut excavation. Each has some merits and demerits like cost component, soil disturbance, wall failure. Out of these, what are the demerits of mechanical excavation? Given answer is costly, bottom soil completely disturbed, sound pollution, seepage flow much more. None of this. The correct answer is bottom soil is completely disturbed, because in case of manual excavation it shall be gradual. In case of mechanical excavation it shall be little bit bigger. As stated in this question, what is the demerits of manual excavation? Given answer is time taking and costly, bottom soil completely disturbed, sound pollution, seepage flow much more, and none of this. Time taking, the correct answer is time taking and hence it is costly. As stated in Z, in what type of soil undercut excavation is suitable? Clay soil, fine grained sand, mixed with silt, coarse grained sand, gravelly sand. None of this. Undercut foundation means actually we are cutting just to enter one person at top, and as per the foundation dimensions, foundation size required, accordingly inside, like coal mines, person will be going inside and he made the excavation as per the size of the foundation, as per requirement of the foundation size. So that this type of undercut excavation, only suitable soil is clay soil. This is the correct answer, clay soil. As stated in G, After excavation, a layer of good material or thick layer of PCC is provided. If it is not provided wrongly, is there any likelihood of construction defect? Given an insurance, soil may be in contact with reinforcement. Appropriate clear cover may not be there. Reinforced may not appropriate. The reinforced may not corrosion free, no harmful effect, none of this. If that PCC, if we do not provide that PCC, our basic problem will be appropriate clear cover of reinforcement may not be there. So, we should provide that reinforcement. For today, I am finishing here. I hope next I will be giving you one or two more parts on same subject, short questions for my beloved young engineers, and I am always available at jcgogoi@gmail.com. I am saying once again at jcgogoi@gmail.com. If you have any problem, then please feel free to contact me. Have a nice day. Please be safe. Please be healthy. And please be positive and with positive impression, positive preparation, and positive attitude. Inshallah.